In this video, we are going to do two questions, right? Two questions from the chapter surface area volume, and that's based on cylinder, cone, hemisphere, right? Let's begin with the first one. This question from the surface area volume says that 3/4 part of a conical vessel of internal radius 5 centimeter and height 24 centimeter is full of water. The water is emptied into a cylindrical vessel whose internal radius is 10 centimeter. What we have to find out is the height of the water in the cylindrical vessel. So what we will do, let's say if I make a cone over here, I'm going to make first a cone. Let's say this be the conical vessel over here. Make it bit like this. And then I'm going to make a cylinder over here. Well, diagram, as I always say, that it's not necessary to make diagram. So further, what does it say is that 3/4 part of the conical vessel. So if I see what's the radius over here, that's given as 5 centimeter. And the height, by default, it has to be the vertical height and not the slant height. And how much is this? If I use H, and H is how much? 24 centimeter. Now further, we can see the dimensions of this cylinder, right? Its radius, let's say if I use another symbol, capital R, to denote the radius of this cylindrical vessel. And let's say after transferring it, the level of water is still this, right? Assume this to be the level of water over here, right? This is what the level of water. And the height for this, let's say if I take the height, which we have to get as capital H, this is what we have to find. Now check here, whatever the volume of water is there, and this is not the whole of it, right? Only 3/4 part of the conical vessel is filled with water, right? 3/4 of the part of the conical vessel is filled with water. So water is up to some height, right? You should understand that water is still here only. This much is water. So when it is transferred from one to another vessel, as you know that volume should remain same. This is the idea we are going to apply. So if I ask you what is the volume of the water here, you should say that the volume here of the water in the shape of a cylinder. So I'll say the volume of the cylinder, which is pi capital R for this, R square capital H is equal to 3/4, right? Because we have to take just this much volume, 3/4 the volume of a cone, which is, what is the volume of a cone? It is 1 over 3 pi R square H. That's 1 over 3 pi R square. And what is H? H, it's very important to use the symbol over here, right? Because you should know that they have a different radius. So pi and pi get cancelled over here. Now I'll plug in the values. What is R? R is capital R is 10. So it is 10 multiplied by 10 into height. And as you know that height is what we have to get. So this is what. And then I can reduce this. You can figure out from here that 3 and 3 get cancelled here. So we are left with 1 over 4. And how much is small r? That's given as 5. So small r, that's 5 into 5. And the height of the cylindrical portion, the whole height, right? Because we have already taken the 3/4, so don't getting confused that why we are taking the whole height. Is the 3/4 of the whole volume. And the height is how much? 24. The height of this is given as 24. Rest we can reduce it. I can see this is divisible by how much? 4 into 6. So this is how much? 6 into 5. That comes out to be 150, right? 25 into 6. And if I transpose this number, it is how much? 100 on the other side. So that should give you the value of the height of the water. This get cancelled. So height up to which it is filled is 1.5 meter. This is what we have to get in this question. This question from the surface area volume, it says 12 solid spheres of the same size are made by melting a solid metallic cylinder of the base diameter 2 centimeter and height as 16 centimeter. What we have to find out is the diameter of this sphere. So let's say first if I make a cylinder over here, this be the cylinder which was melted, and this is a solid cylinder, not an hollow. So these are the bases, and this is melted to form how many? 12 spheres, right? So these are, let's say these are the spheres. You should know that this is not a circle over here. I'm talking about a sphere, right? And you should be clear that this is solid, and so is this. This is also solid. Now, what we can know here, let's write down the dimension, what we know about the dimension. So I can see that the diameter is 12 centimeters. So if I take the radius, I use capital R over here. The radius is 1 centimeter. And height, let's say if I use capital height over here is how much? 16 centimeter. And what we have to find out, say radius of this. So I took the radius of this as R is what we have to get. Well, it is very clear that let's say the volume of this should be equal to 20 or 12, sorry, 12 times the volume of say this, which is I'm using V1 for this sphere. So now let's write down the formula. What is the formula for the volume of a cylinder? It is pi R square H. It is important to remember we have used capital R and capital H for this dimensions. Should be equal to 12 times the volume of this sphere. And what's the volume of sphere? It's 4 over 3 pi R cube. Now check what things getting cancelled here. This and this getting cancelled by 4 times. I can even cancel pi and pi. So I've cancelled this pi. Let's say if I show you again. I can replace R with 1. So it's going to be 1 into 1 and height which 16 height of the cylinder. And this is how much? 4 into 4, that is 16 times R cube. So R cube, R is what we have to find out in this case, right? So this is R cube. Check here, this side it is 16 and 16 get cancelled. So R cube comes out to be 1. So R is what? 1. Right. So this is what we have to find out the diameter, right? We got the radius, not the diameter is for the question. The radius we got here as how much? 1 centimeter. So the diameter, as you know, is twice the radius. So it's going to be 2 centimeter. That's how we'll do this question.